Hello everyone, welcome back to my channel InphuSecLab, and today we are going to continue our series on TryHackMe web app pen testing. The vulnerability that we're going to cover today is Server-Side Request Forgery, which is short for SSRF. So what is it? Let's dive into this. Introduction. The landscape of the web attack constantly evolves, with threat actors devising sophisticated methods to compromise our system. As each day passes, the expansion of the web-based threats warrants the need for robust security measures to counter ever-advancing tactics employed by malicious actors. In this room, we will discuss a similar attack known as a server-side request forgery, or SSRF. SSRF is a web application security vulnerability that allows the attacker to force the server to make unauthorized requests to any local or external sources on behalf of the web server. SSRF allows an attacker to interact with internal systems, potentially leading to data leaks, service disruption, or even remote code execution. The learning objectives of today is to understand the working of SSRF, practically testing various types of SSRF, a few important tools for exploitation, some key mitigations and defensive measures. Learning prerequisites. Before attempting this room, we should complete the following rooms: how website work, some protocols and servers, and OWASP top 10. Okay, let's try to add this one to the host. Let's see what's the IP address. This is the one. Paste. Oh no. Okay, after adding the IP address to the host file, we now can access the target machine. Let's try it. What's it? TryHackMe, HRMS, HTTP, HRMS. There we go. Okay, cool. Anatomy of an SSRF attack. When developing network software, it is common to make requests to external servers. Developers often use these requests to fetch remote code sources, like software updates or import from other applications. While these requests are typically safe, improper implementations can lead to a vulnerability known as SSRF. An SSRF vulnerability can arise when user-provided data is used to construct a request, such as forming a URL. To execute an SSRF attack, an attacker can manipulate a parameter value within the vulnerable software, effectively creating or controlling requests from other software and directing them towards other servers or even the same server. SSRF vulnerabilities can be found in various types of computer software across a wide range of programming languages and platforms, as long as the software operates in a network environment. While most SSRF vulnerabilities are commonly discovered in web applications and other network software, they can also be present in server software. OWASP ranking. SSRF is a formidable security threat, earning a spot in the OWASP top 10 list, making it imperative to understand and defend against it as it jeopardizes data integrity and application security. As per OWASP, factors regarding SSRF are mentioned below. max incident rate. It suggests how often this vulnerability has been encountered relative to other vulnerabilities in the OWASP top 10. Average incidence rate. It shows how common this vulnerability is compared to others. Indicate average weighted exploit. Indicates the average difficulty or effort required to exploit SSRF vulnerability. Average weighted impact. Average potential impact or severity of exploiting an SSRF vulnerability. Max coverage. It indicates how much of the system has been exploited due to this vulnerability. Total occurrences. Total exploitations due to this vulnerability that OWASP has analyzed. Total CVEs. Total CVEs about SSRF. These are CVE 2021, 21, 311, 2018, 11, 759, and CVE 2017, 9506. This data on OWASP is from 2021. The risk of SSRS. Data exposure. As explained earlier, cybercriminals can gain unauthorized access by tampering with requests on behalf of the vulnerable web application to gain access to sensitive data hosted on an internal network. Reconnaissance. An attacker can carry out a pro-scanning of internal networks by running malicious scripts on a vulnerable server or redirecting them to script hosted on the external servers. Denial of service. In this common scenario that internal network or servers do not expect many requests. Therefore, they are configured to handle low bandwidth. Attackers can flood servers with multiple illegitimate requests, causing them to remain unavailable and to handle genuine requests. What is the average weighted impact of SSRF vulnerability as per OWASP top 10? Average weighted impact is going to be 6.72. Types of SSRF. The basic SSRF is a web attack technique where an attacker tricks a server into making requests on their behalf, often targeting internal servers, system, or third-party services. By exploiting vulnerability in input validation, the attacker can gain unauthorized access to sensitive information or control over remote resources, posing a significant security risk on the targeted application and its underlying infrastructure. Scenario number 1. SSRF against a local server. In this attack, the attacker makes an unauthorized access request to server hosting the applications. The attacker typically supplies a loopback IP address or a local host to receive the response. The vulnerability arises due to the application's handles input from the query parameter or API calls. For example, in the HRMS application, there's a feature that loads additional pages based on the URL parameter. For example, navigating to the following URL would load the copyright page of the application. This feature is intended for internal use and is designed to request and display pages from local servers, hence using localhost in the query. However, due to insufficient validations of the input URL, an attacker can manipulate this functionality for SSRF attacks. By changing the URL parameter to point to other pages or services, the attacker can force the HRMS server to make requests to other pages. For instance, if the attacker uses a URL like this one and conflict is a valid page, the HRMS server will attempt to fetch the content of this page and displays the result. The main idea is to forge a legitimate request and make the server perform an unintended action. How it works. Suppose you have been tasked to backtest the HRMS website and identify any SSRF loopholes. Visit the website and get the login page protected through a user and password. We will notice that once we visit the web page, it automatically redirects to the following URL. The web page shows the copyright status of the website. So let's try that. And obviously we can see that this is the redirect URL copyright. So meaning the application is currently fetching the content of the copyright file on the server. This means that the developer has probably made some mistake while handling a file showing the copyright status. Here's a code of the page that takes a query parameter. Yeah, the input parameter lacks the adequate filtering and loads wherever the parameter is provided from the local host. So now we try to change the copyright to hello, and we should get an error. This is a reconnaissance step. Over here, hello.php is not found. So the page calls another PHP file and displays on the current page footer. What if we call sensitive files like connection.php or config.php? When we try to access this file, we will see that the footer of the page shows the content of the file, essentially showing us the exact credentials, which would look like something like this. Okay. So let's try connection.php first. See what we get. Okay, so the file doesn't exist. So, config. Yep. And because the file exists, the application is going to show the content of the file, which is here. We have the credential and the password. 1, 2, 3. Something's wrong. Also, if you notice that we also discover another page, which is admin.php. So HRMS admin 1, 2, 3. And we got a flag. What is the URL? What's the flag value right here? What is the URL HRMS admin? What is the password for HRMS admin 1, 2, 3? And what is the admin URL for HTTP HRMS dot? TryHackMe. What was it? So let's try signing up first. Okay. Oh, this is the URL. The internal network. There we go. Let's continue to our second scenario. In complex web applications, it is common for a front-end web application to interact with the back-end internal servers. These servers are generally hosted on the non-routable IP addresses, so an internet user cannot access them. In this scenario, an attacker exploits a vulnerability web application's import validation to trick the server into requesting internal resources on the same network. They could provide a malicious URL as input, making the server interact with the internal server on their behalf. For instance, if an internal server provides database management or administrative control, the attacker could grab a URL that initiates an intended action on the system when processed by the vulnerable web application. Technically, this is achieved through manipulated input, such as special IP addresses, like 192.168. etc. or 10.10 something, or domain names, internal database.hrms.TryHackMe. When not properly sanitized, these inputs can be used in functions like HTTP requests or file inclusions within the web application. The server interpreting these requests as legitimate, then inadvertently perform actions or retrieve data from the internal services. Moreover, since these internal servers may lack the same level of security monitoring as external-facing servers, such exploitation can often go unnoticed. The attacker might also use this method to perform reconnaissance within the internal network, identifying all the vulnerable systems or services to target. So how it works. In this case, We'll try to access the inaccessible internal resources through direct request. Now that we have acquired the credentials for the login page, we log into the dashboard. Once we log into the HRMS web app, we'll see a dashboard listing employees and their departments. There's a chart that shows the employees' data and salaries. From this config file, we can see that the admin panel is hosted on 192.168.2.10/admin.php. If we try to log in the admin panel, it is not accessible directly. Let's try to access it. Okay, let's try it. Right, let's see the page loading. It seems let's try this. HRMS admin 1, 2, 3. Now let's try this one. Yeah, the same thing happened. You can see the page loading, but I never loaded any resources from the internal network. And eventually it's going to show this error. We have no route to the IP address as it's a private network IP and can only be accessed by a machine within the same network. If we check the source of the HTML, it shows that a dropdown takes the URL from the internal system and renders the data. The details of all employees are being rendered from the 182.168.2.10/employees.php. That's great. So the dropdown is accessing the internal system. What if we try to change the request shutdown? Instead of uploading the employee page, we forge the request and send http://192.168.2.10/admin as a parameter to servers. Let's do that. Use the inspect element options and change the dropdown. Let's do that. Use the inspect element option and change the dropdown value of salary from salary.php to admin.php as shown below. Continue. Right click on this one, inspect. We add the category dropdown right here. And what do we do? So right click this one, click inspect, and it's going to take you right to the element right here. And we see the values 182.168.2.10 employee salary. So let's try changing this one to admin.php. And now we try to select salary option. And we got to the internal login page. Nice. Alright, let's try using the same credential, which is HRMS admin, and then HRMS admin 1, 2, 3. Login. Okay. Something's wrong. Let's try one more time. Inspect. This one should be admin.php. And then from employee, we change to salary. Nothing happened. Let's go to profile. Training. Employees. Okay, let's try it again. I'm not sure what happens. Let's see. We have the drop down menu right here. We edit the values. Here we look and we select the page. Oh, right here. So we weren't able to actually use the credentials we found earlier to log in the internal admin dashboard. That's fine. Is accessing non-routable IP address possible if the server is vulnerable to? Yeah. Blind SSRF refers to a scenario where the attacker can send requests to a target server, but they do not receive direct responses or feedback about the outcome of the request. In other words, the attacker is blind to the server's responses. This type of SSRF can be more challenging to exploit because the attacker cannot directly see the results of their actions. We'll discuss its various examples. Like SSRF with out-of-band. Out-of-band SSRF is a technique where the attacker leverages a separate out-of-band communication channel instead of directly receiving responses from the target server to receive information or control the exploit server. This approach is practical when the server's responses are not directly accessible to the attacker. For instance, the attacker might manipulate the variable server to make a DNS request to a domain he owns or to initiate a connection to an external server with a specific data. These external interactions provides the attacker with evidence that the SSRF vulnerabilities exist and potentially allows him to gather information about, such as to gather additional information such as internal IP addresses or the internal network structure. How it works. Once again, try to log in the dashboard and click on the profile tab. We'll see that it redirects to the profile.php and then it's fetching the content of the getinfo.php file, which displays a message sending analytics data. What's happening here? Once we load the profile.php, it sends data to an external page named getinfo.php, which is probably used for analytics and logs. And this is the source. This is the code that shows the actions above. Source code analysis of the page shows that it is reading URL parameters and without performing any validation. It sends the information to the server mentioned in the URL parameter. Here, an attacker can redirect the request to the server, thus getting additional information for exploitation or data pilferage. On the attack box, create a file named server.py and add the following code. Channel server.py and paste. So this code will receive all the content and save it to the file named data.html on the server. To obtain the data, we first need to start a lightweight server. We can run this one. Okay. Sudo chemo server.py. Okay. And sudo python server py. And sudo python server. Is there any flag? Nope. Okay, so now we have set up a listening on our attacking machine. Now we can open the browser and open this URL and click on this URL. We'll have a slight modification, which is we have to replace the string with the attacker IP address, which is in this case going to be 10.10.175.40. If you're curious, I get it from here. 175, not 172. 40 port 8080. So now let's check the data.html. Let's we have this file right here, data.html. Cat data. Okay, that's a lot. Let's try seeing that on a real browser. What am I doing? Okay, so let's take a look at this data.html file, see how it looks on the browser. Okay. As we can see right here, it shows a lot of information about the internal system. The system information, the build dates, the server API, the configuration file, and its location, etc. So again, if you get access to the internal network, then this is one of the files or information that you can gather from the target machine. Semi-blind SSRF or time-based. Time-based SSRF is a variation of SSRF where attacker leverages timing-related clues or delays to infer success or failure of their malicious request. By observing how long it takes for the application to respond, the attacker can make educated guess about whether the SSRF attack was successful or not. The attacker sends a series of requests, each targeting a different resource of a URL. The attacker measures the response time for each request. If a response takes significantly longer, it may indicate that the server successfully accessed the target resource, implying a successful SSRF attack. Answer the questions. Now you have the data.html file. You can actually answer these questions based on the file. Does outbound SSRF always include a technique in which an attacker always receives direct responses from server? No. What is the value of virtual directory support on the PHP server per the logs data is stable? What is the values of PHP extension built on the server? It's going to be this value. What type of SSRF does it give as a direct response or feedback? That's blind. Crashing the server. An attacker could abuse SSRF by crashing the server or creating a denial of service attack for other hosts. There are multiple instances like WordPress or Cairo SVG, where attackers try to disrupt the availability of the system by launching SSRF attack. In this demonstration, we'll illustrate how an attacker can exploit a web application to cause a denial of service on server. In our scenario, the vulnerability is exploited by supplying a malicious URL that points to a resource which, when accessed by server, leads to excessive resource consumption or trigger a crash. For example, the attacker might input a URL pointing to a large file on a slow server, or a service that responds with an overwhelming amount of data. When the vulnerable application naively accesses this URL, it engages in action that exhausts some resources, leading to a slowdown or complete crash. How it works. Once we log in the dashboard, we'll see a tab called Training in the navigation bar, which is used to load the training content for the employees. Once we click on the tab, we see that it redirects to the URL HRMS.TryHackMe/URL with the ID parameter, and these are values, which shows the training content. Let's try that. We logged in. Oh, okay. So we're logging in as training. And this is the URL we talk about. Let's right click and see the go. Okay, there's really nothing to see here. We notice that the URL.php file is loading external content display here. What if we try to load any other content? We can try by inputting this IP address 10.10.10.10. 10.10. And look like we got a response back. So as you can see, it opened the file for you. Now that we know that server is portable to a basic SSRF, let's explore the code of the URL.php to make it crash the server. Now we have to sign out first. So to make it easier, I'm going to close this one. Go back to the profile page. Now we'll go into the home page and sign up. Now, if you remember, over here is loading the copyright file. So now I change it to the URL because we want to see the source code of this file. And over here, now we have access to the URL.php file. Let's take a look at the code. In reality, we have to go through the code from the beginning to the end. But here in this case, in order to save time, we go to the block that matters the most. So the URL.php file is checking the size of the image. If the image is less than 100 kilobytes, it's going to display the image. Otherwise, an error will be output, server will crash. So here, basically that's the explanation. It shows that the URL.php lost an image. If the image size exceeds 100 kilobytes, it shows a memory outage message and throws an error. So now, what we can do is try to load an image whose size is bigger than 100 kilobytes. And TryHackMe has made it easier for us by preparing this image right here. So let's try that. But first we have to log in again. HRMS admin, RMS admin at L3. We go to the training page. This is a training method, and we're going to load a big image right here, and we should crash the server. Image server crashed. We get a flag. All right, we can see that the threat posed by SSRF vulnerabilities extend beyond unauthorized data access or internal network exposure. It also includes the potential to disrupt or completely incapacitate critical server operations. By manipulating a vulnerable server to make unintended requests, an attacker can overload the system, leading to crashes that result in denial of service. And we got a flag right here. Mitigation measures for SSRF are essentials for preserving the security and integrity of the web applications. Implementing robust SSRF mitigation measures helps protect against these risks by fortifying the application's defenses, preventing malicious requests, and bolstering the overall security postures. As a critical element of web application security, SSRF mitigation measures are instrumental in preserving user data, safeguarding against data breaches, and maintaining trust in the digital ecosystem. A few of the important policies are mentioned. Implement strict input validations and sanitize all user-provided input, especially any URLs or input parameters the application uses to make external requests. Instead of trying to block lists or filter out disallowed URLs, maintain allow lists of trusted URLs and domains. Only allow requests to these trusted resources. Implement network segmentation to isolate sensitive internal resources from external access. Implement security headers, such as content security policy, that restricts the application's load of external resources. Implement strong access controls for internal resources, so even if an attacker succeeds in making a request, they can't access sensitive information without proper authorization. Implement a comprehensive login and monitoring to track and analyze incoming requests. For unusual or unauthorized requests and set up, look for unusual or unauthorized requests and set up alerts for suspicious activity. Answer the question, what of the following is a suggested approach while handling trust URLs? No, we don't filter out. We maintain allow list. And since SSRF mainly exploits server-side requests, is it optional to sanitize the input URLs or parameters? Nope. It's always important to sanitize the input URLs and parameters. Conclusion. That's it for the room today. We have covered SSRF, the vulnerability, how to detect and how to exploit it. Or we also learn how to leverage SSRF vulnerabilities to perform other exploitations or web applications by, for example, exposing internal data, sensitive data, recognizing internal infrastructures, or performing a denial of service attack on the target servers. That's it for the room today. I hope you learned the basics of SSRF and enjoy the room. If you have any questions, feel free to reach out to me. And thank you for watching the video. Have a good day. Bye-bye.